Hi everyone, welcome. Today we will be diving into a particular LeetCode problem called reverse linked list and exploring an efficient solution to solve it. Well, linked lists are fundamental data structures used in many programming languages and applications. Understanding how to manipulate the reverse linked lists is a crucial skill for any programmer. And this problem in particular challenges us to reverse the order of a given linked list and return the new head of the reversed list. So without further ado, let's get started. The main idea behind this solution is to reverse the pointers of the linked list iteratively. And by modifying the pointers, we change the direction of the list and effectively reverse its order. We start by initializing two pointers, prev and curr. Prev is initially set to none, indicating that there is no previous node, and curr is set to the head of the linked list and representing the current node we are working with. The core of the solution lies within the while loop. We iterate through the linked list, one node at a time, until we reach the end of the list. In other words, when curr becomes none. So inside the loop, we perform three important steps. First, we store the reference to the next node in a variable called next node. And this step ensures that we don't lose the reference to the remaining part of the original list. And next, we update the next pointer of the current node to point to the previous node. And this action effectively reverses the direction of the pointer. And by doing this, for each node in the list, we gradually reverse the order of the list. And finally, we move both prev and curr one step forward. We set prev to the current node and the curr to the next node. And this prepares us for the next iteration of the loop where we reverse the pointer of the next node. And by repeating these steps until we reach the end of the original list, we reverse the entire linked list. The new head of the reversed list is the node that was previously the tail of the original list. And that's what we return as the result. And the beauty of this solution lies in its simplicity and efficiency. It operates in a single pass through the list, manipulating the pointers as it goes. And it doesn't require any additional data structures and achieves the reversal of the list in place. And the time complexity of this solution is O of n, where n is the number of the nodes in the linked list. And this linear time complexity arises from the fact that we iterate through each node in the list exactly once. And during the while loop, we perform constant time operations, such as updating pointers and moving to the next node. Since the number of operations is directly proportional to the number of nodes, the time complexity scales linear with the size of the linked list. The linear time complexity makes the solution efficient and practical even for large linked lists. It demonstrates the effectiveness of the iterative approach in reversing a linked list. And moving on to the space complexity, it is big O of 1, which is constant. The solution uses a constant amount of extra space to store the prev, curr, and next node pointers. The space required does not depend on the size of the input linked list, so it remains constant regardless of the input size. This constant space complexity is highly desirable as it minimizes the memory requirements of the algorithm. It means that the amount of additional memory used by the algorithm does not increase with the input size. This is particularly advantageous when dealing with large linked lists or in scenarios where memory is a limited resource. By having a linear time complexity and constant space complexity, this solution strikes a good balance between efficiency and memory usage. And that brings us to the end of our tutorial on the reverse linked list problem. Reversing a linked list is a fundamental problem that often appears in coding interviews and real-world programming scenarios. Being comfortable with manipulating linked lists and understanding the underlying concepts will give you an edge as a programmer. And remember, practice makes perfect. So I encourage you to try solving similar problems on your own to strengthen your understanding and problem-solving skills. And if you found this tutorial helpful, don't forget to give it a thumbs up and subscribe to the channel for more coding tutorials and problem-solving techniques. Your support is greatly appreciated. Happy coding and thanks for watching. Goodbye.